And we're talking set 1, or week 9, set 1, SWYK number 2. We can actually solve systems that involve quadratics and linear functions by graphing. So, you know how to graph a quadratic, right? First you got to find the vertex. You know, your little opposite, oops, get my writing tool on here, opposite of b over 2a. And when I did that, I got positive 1. Then I plugged it into the equation, right? Plugged it in for x's, plugged them in, and ended up with 7. So 1, 7, and over 1 up 7, right? And then I could use my, my 1a, 3a method of graphing. So 1a is negative 1, 3a is negative 3. So over 1, down 1, over 1, down 3. And then, of course, we just copy those to the other side. And, of course, we can do 5a, which in this case is negative 5, so over 1, down 5. Copy the points to the other side of the axis of symmetry and graph the parabola. Well, this is old stuff, right? Graphing, you got the y-intercept at 6 and a slope of 2. So you got your dot there and up 1 over 2, up 1 over 2. And you can use it down 1, back 2, down 1, back 2. Does have to have a positive slope. You can notice that the line touches the parabola in one spot right there, located at 0, 6. It does say type in ordered pair, so make sure you don't just write 6, make sure you write 0, 6. Otherwise, it'll count you wrong, and we know that you knew what you were doing. Question 2. Okay, now, we've got two parabolas. One thing that we can do, and I'll go through, in question 2, I did things a little bit differently. I decided to use substitution, right? Hence, solve as a system using substitution. So, what I did was I took this and I substituted it in here. Then you'll notice that I started to move things around, put the x squareds on the same side. In fact, I've decided to put everything on the same side. And so what that did was it gave me this equation right here to solve. Now that's pretty easy to solve because we can do that with factoring. Notice that I looked for a GCF, which in this case is 3x, pulled it out. And then of course you set your factors equal to 0 and solve. Now this question only said to find the x coordinates. That's it. So once we set our coordinates, our 3x equal to 0 and our x minus 2 equal to 0, and then we solved them, and we ended up with 0 and 2, we're done with the question. They did not ask for the entire coordinate. All they asked for were the x coordinates. So pay attention to what they're asking for. Sorry. Now in question 3, you can see that they just said solve. So so they're now indicating they want the x and the y. So what I did was I graphed both of them. I graphed the parabola, as you can see right here. And I graphed the line. Notice that it crosses in 2 places. And in order to make your own graph, you'd have to be a little bit careful. But I found out that negative 1, 5 was one of the answers right there. And I also found out that negative 4, 8 was also one of the answers. But if you want to back that up with substitution, you can, right? So we set the two y's equal to each other, basically substituting into this. That's all we're really doing, pushing everything over to the same side, and that gives me x squared plus 5x plus 4. Definitely a factorable thing where the two factors of 4 that add up to 5, x plus 1, x plus 4. That gave me negative 1 and negative 4. Okay, so what do I do to find the y values that go with it? I would have to plug them in to the equation. Now, which equation would be easier to plug them into? Whoops. which equation would be easier to plug them into? I think it would definitely be easier to plug them into that second one. So, the opposite of -1 plus 4, and that's where we end up with 5, right? And the opposite of -4 plus 4, that's where we end up with 8. You could plug them into the quadratic if you want to, but I think that would take way too much of your time. Question 4 shows us that we are substituting two quadratics. And you'll notice that I took everything on this side and pushed it to the other side. And what that did was gave me this equation right here. I noticed that there was a GCF of 2 that I could pull out. So I pulled out the 2, right? Then I factored what was left. Anything with factors of 3 that add up to 4. And that's where I got the x plus 3 and the x plus 1. So now I knew that my x values were -3 and -1. So what did I do? I plugged them into one of the equations. So I chose the second equation and I plugged them in. So here's me plugging in the -3. You've got 9 and then you got a negative in front. You can't get rid of that because you got to go with the square first. Trust me on this. Use parentheses if you're in doubt. -3 times -3 is 9. So those two canceled out, leaving me 1. So -3 produced the y value 1. And plugging in the -1, the -1 squared is +1. Don't forget that negative out in front of that. So that creates -1. And then -3 times -1 is 3 plus 1. So these are going to cancel and leave me with 3. And that's where I end up with that right there. So those are my coordinates, just by doing substitution. Now we can graph that too. Hold on, let me shoot it up on the graph there. If you want to look at the graph too, just to double check. Take a look at this and we can see that -1,3 is correct and -3,1 is correct. So you can use the graphing software Desmos.com to double check your work. But you do need to know how to do the substitution. Trust me. So do the substitution, verify with a graph. And that's enough for, I think. Let me just double check. Yes. All right. You have a wonderful day and do well on SWYK number 2.